investigation, the Boston Athletic Association discredited and disqualified Ruiz for cheating her way through the marathon. She was arrested. The Ruiz scandal provided plenty of fodder for the media. The ABC show Fridays poked fun. Officials became suspicious when she crossed the finish line of the 26.2-mile event wearing open-toed sandals and smoking a cigarette. Someone who personally knew Ruiz told the media, "If you ask her to shed 5 tears, she'll shed exactly 5. Ruiz may well be an ill-famed poster child for marathon offense. As a New York Times journalist put it, her name endures like a fragile porcelain figure that has been restored after breakage. The Rosie Ruiz incident presented a conundrum to marathon organizers. Her cheating was obvious, but it exposed the fact that policing a race with thousands of participants is a daunting challenge. How could they prevent future frauds? Engineering provided a solution from a combination of inventions originally fashioned to address 2 very different issues. 2. In 1959, railroad companies in the United States faced a vexing challenge. The rail system included nearly 1.6 million freight cars, and the company officials needed to know the precise location of each car at midnight every day. The whereabouts of these rail cars had revenue implications, but there was no way to track them. What was needed was an automated means of identifying and locating the cars. Around that time, David Collins joined the operations research department of Sylvania, an electric products company. Collins, who had graduated with a master's degree from the Massachusetts Institute of Technology, loved being an engineer. He enjoyed it so much that he would sometimes joke with his wife that in his next life he wanted to write TV and movie scripts in which engineers were superheroes. Collins heard about the railroad challenge from a colleague. Having worked as a college intern for the Pennsylvania Railroad, Collins knew something about the system. "It fascinated me," he recalled. "I started kicking this project idea around in the lab." Each railcar was labeled with a horizontal serial number, which was a combination of a 6-digit company code and a 4-digit car code. Like the cattle brands of Western ranchers, these codes came in different reflective colors, red, blue, and white, on a non-reflective black background. They also came in different widths and fonts and had no standard location on the cars. The rail cars themselves came in different sizes: tank cars, box cars, and flat cars, the last of which sometimes carried 9-foot-tall semi-trailers. These inconsistencies made any attempt to read the rail cars' codes difficult. The trains also moved at different speeds, as fast as 60 miles per hour, or at times crawling toward a way station. The need for a dynamic scanning technology that could overcome these problems was obvious. So you had a coding system that had been in place for 50 years, but there was no way to acquire that information and make it accessible in machine-readable form, Collins said. He started work on the project in his personal time, eventually gaining his boss's support. Overall, he said, it was like something that went on at the back of the ranch that nobody really talked about. Collins' idea was to develop an optical sensor system that could send a white light beam out to a distant code and decode the signal that reflected back. He focused on primal design elements, such as the code spot size, the specific area where the light is projected and reflected back, scan rate, how many times the code needs to be read each second for an accurate reading, and depth of field, the farthest reading range of the scanner. Initial experiments proved vexing. One of Collins' fellow engineers, Frank Stites, was also baffled by the challenge, but serendipity intervened. Stites inspired Collins to wonder, why not turn the code labels sideways? It was a clever idea. Scanning the codes vertically, that is, converting a picket fence arrangement to a ladder rung style, worked out to be a technically superior alternative. Instead of aiming steady white light beams at the passing trains, which was usually a hit-or-miss proposition, Collins designed a moving light source with rotating mirrors. His scanner was now able to consistently